Okay, continuing with section 7.1 in this video. On occasion, factoring or simplifying can best be done by first rewriting the expression in terms of just one trig function, or in terms of sine and cosine only. These strategies are shown in examples 4 and 5 respectively. So in example 4, we want to factor this trig expression. Cosecant squared minus cotan of x minus 3. And usually we'd like to see something like x squared minus x minus 3. We could factor that. But here, cosecant and cotan are different. So that would be like x squared minus y equals 3. We can't factor it until we get everything in terms of a single trig identity. And a good rule of thumb, when you see something squared, always think to those three Pythagorean identities. So let's take this cosecant squared and replace it. And if we look to the formula sheet, that cosecant squared is replaceable with a 1 plus cotan squared of x. And then, we have a minus cotan of x. And then minus 3. So let's see, we have this quantity and then minus after that. So these parentheses are kind of not necessary. We can just drop them. And now we can combine our like terms of just these numbers. So now we're going to have a cotan squared of x minus cotan of x. And then negative 3 plus 1 is minus 2. Again, if you want to think of these in terms of x to make the factoring a little more obvious, we'd have an x squared minus x minus 2. How would we factor that down? Well, it's going to be x times x at the beginning, or cotan times cotan. And then the factors of negative 2 that add up to negative 1. Well, minus 2 plus 1. Minus 2 plus 1. And there's our factorization. Here in example 5, simplify the trig expression. We have sine of t plus cotan of t times cosine of t. And the other strategy that was mentioned there at the opening was get everything in terms of sine and cosine. That's already in terms of sine, so that's going to stay put. And I'm going to put it over a 1. Plus cotan. Tangent is sine over cosine. Cotan is its reciprocal. So that would be cosine over sine. And this is times cosine over 1. So let's see now. When we combine these numerators here, we're going to have a cosine times cosine, or cosine squared. So we still have our sine of t over 1 plus cos times cos is cos squared of t over sine t. And now we have two fractions with different denominators. The common denominator would be our 2 that we already have multiplied, or 1 times sine of t is sine of t. To get a sine of t denominator on this side, we'd have to multiply the numerator by the same sine of t. So now we have sine times sine is sine squared of t, plus our other numerator, cosine squared of t. And now these share the common denominator of sine t. Sine squared plus cosine squared. By the Pythagorean identities, that's equal to 1. This numerator is substituted in with a 1. And now we just have our denominator sine of t. 1 over sine of t. What's the reciprocal of sine? Well, that's cosecant. Cosecant of t. So look at that. We went from something as, unruly as that, down to a simple cosecant of t. This stuff is very useful in calculus when you're faced with something like this and you want to perform a calculus operation on it. It might be impossible, or nearly impossible, to do the required calculus on this. But if we know these simplification techniques, we can get it down to a simple cosecant of t, and that greatly simplifies the problem. In example 6, perform the addition and simplify. So we want to add these together and then simplify the result. So again, we have two fractions, different denominators. And the common denominator between the two is if we multiply those two denominators together. So my overall denominator is going to be sine of theta times that quantity. Sine of theta times the quantity, 1 plus cos of theta. And let's see, to get this to be agreeable with the common denominator, we had to multiply it by a sine of theta. So we multiply the numerator also by sine of theta. Sine of theta times sine of theta is sine squared of theta. plus. Now this denominator was just a sine of theta. We had to multiply it by this denominator to get the common. So we're going to multiply the numerator cos times this also. So we're going to have the cos of theta, cos of theta, times that quantity, 1 plus cos theta. And this numerator, let's FOIL this out. We're going to have cos of theta times 1, cos of theta times cos of theta, and where did that squared come from? That's not supposed to be there. All right, let's clean this numerator up a little bit. We have our first sine squared of theta, plus now we have cos times 1 is cos theta. And then we're going to have a plus cos times cos is cos squared of theta, all over our common denominator. Sine of theta times 1 plus cos. I'm not foiling this out. Maybe, hopefully, this numerator will simplify down a little bit and we'll be able to eliminate something with what we have in the denominator. So let's see. Now that numerator, it's 3 terms, but 2 of them are sticking out like sore thumbs. We have a sine squared plus a cosine squared. Well, sine squared plus cosine squared, we can replace those with a 1. We're going to have a 1 plus this cosine that we have left. 1 plus the cos of theta over sine theta times 1 plus cos theta. Look at that. So the numerator 1 plus cos and the denominator 1 plus cos will cancel. But do remember, this sine theta is a denominator and it's going to stay a denominator because we sort of had a placeholder of 1 up here. And that is equal to 1 over sine theta. And again, that is just like 1 over sine is the reciprocal with cosecant theta. So we went from all of this, added it together, common denominator, and it all come down to a nice simple cosecant of theta. Here's 3 practice problems, just like we had. The first one up here, try to break that numerator apart. It's something squared minus 4, difference of squares. For the next one, FOIL it out and see what you can simplify a little bit. Again, there is more than one correct answer for each. And the last one here, perform the addition or subtraction. Secant plus 1 minus 1 over secant minus 1. Multiply them together to get your common denominator. Find your new numerators and simplify. So pause the video, try them out, and turn it back on, see how you did. Let's see, in the first one, factor the expression and simplify with the identities. Well, the numerator, as I gave you a little hint, is something squared minus 4. A perfect square minus another perfect square is the sum and a difference. So we're going to have the same terms with a plus and a minus in there. And our first term is cos squared. So it's going to be cos of x times cos of x. That gives us cosine squared. And our 4, the square root of 4 is 2, plus 2 and minus 2. So cos of x plus 2, cos of x minus 2 over our denominator, and look at that, cos of x minus 2. You can look, when you're dealing with something like this, look to the denominator maybe, and that might give you a clue as to what direction to head. Our denominator is one of the terms when we break apart our numerator into 2 factors. So these will cancel, and we're left with just the cos of x plus 2. See here in number 71. Perform the multiplication, use the fundamental theorems to simplify. More than one correct answer. So sine of x plus cos of x quantity squared. That's like sine of x plus cos of x times itself. Sine of x plus cos of x. Might be easier to see, foiling it out in this way. So first term times first, sine times sine is sine squared of x. First times last, sine of x times cos of x plus sine x cos x. Inner terms, cos times sine is another term, sine x cos x. And then our last terms, cos of x times cos of x is cos of x, or cos squared of x. So we can combine these terms, sine of x cos of x, and another sine x cos x. That will turn into a plus 2 sine x cos x. And what do we do with the last terms? Sine squared plus cosine squared, that's a Pythagorean identity. Sine squared plus cosine squared equals 1. So here we have 1 plus 2 sine x cos x, or you could have 2 sine x cos x plus 1. Either way, same thing. Much simpler than what we started with. And here's our last one. And this said perform the addition or subtraction and simplify. So we're subtracting two fractions, different denominators. We need a common denominator. And that is these two multiplied. And we have secant plus 1 and times secant x minus 1. That's a sum and a difference. So the shortcut is our first terms squared, secant squared of x, minus, always minus, our second term squared. 1 squared is 1. So secant squared minus 1 will be the common denominator. So in the first fraction, we were missing the term secant x minus 1. We multiply the numerator by secant x minus 1 and get secant x minus 1. For the second one, our denominator was secant x minus 1. We were missing the secant x plus 1 term. And here, don't forget, we are subtracting. So this is minus the quantity 1 times this denominator. Secant x plus 1. Secant x plus 1. Now, when we distribute the negative, we're going to have minus secant x, and then this will turn into a minus 1. So this is going to turn into a minus 1 when we distribute the negative, and the parentheses disappear. So let's see what happened. Now we have secant of x minus secant of x, so those cancel each other out. And our numerator is now negative 1 minus 1, which is negative 2, over secant squared minus 1. Well, secant squared minus 1, again, you see that squared, think right to the Pythagorean identities. Secant squared minus 1 is the same thing as tan squared. We had our fraction. Common denominator, found our new numerator, simplified it down to a single term. One trig function in the denominator. Homework for this section is just 5 problems.